try and do some experimenting. Right. We're going to look at four-sided figures a lot today and look for parallelograms and what special traits they have. It says any polygon with four sides is a quadrilateral. That's what quad meant, just four. However, some quadrilaterals have special properties and therefore they'd be named specifically. We will be looking at a parallelogram a lot today. The parallelogram's definition, and you need to be writing down definitions, remember. So if you're on lesson 6.2, got some space at the bottom there. A parallelogram is a quadrilateral with two pair of parallel sides. Two pair of parallel sides. That's where it gets its name, parallelogram. So if you're ever unsure if it's a theorem or the definition, think about the name of it. Name parallelogram, it's going to have parallels. To write the name of a parallelogram, there is a symbol, and it's like a little miniature parallelogram picture. So this slanted shape, that's a parallelogram symbol. Got an enlarged picture of parallelogram ABCD. I marked the arrows on there so that you're sure that you have opposite sides, both pair of opposite sides parallel. So parallelogram ABCD written with the symbol. And down below here I just clarified parallels. So besides the opposite sides being parallel, we're going to do some experimenting and see what other properties there are today. I think the hardest part of what we're trying to experiment with today is drawing so that we have some parallels. Because it's, you guess at what's parallel, but to definitely have parallels, we'll have to maybe use sides of our ruler without moving it at all. So leave this. Okay, so let's try on your paper to create some parallels. Graph paper does work. Your lined paper could work also. Most of you have lined paper at your desk? Yes or no? Got some paper with lines? I don't think that just using the free paper would probably work real good. Just because we're going to use the lines on the paper for two parallels. So if you have some lined paper, let's grab that and get your ruler out. Okay, now I don't have lined paper up here, so I'm going to just describe what I want. I want you to highlight one line on your paper and go down about 5 lines and highlight another one. With your straight edge on the lines. So you're going to use those two as a pair of parallels. I want you to go at a slant when we do the next step. Okay, go ahead. Okay, now the next step, we're going to use the two sides of the ruler as parallel without moving it. So position your ruler at some kind of an angle. Let's not go perpendicular, go at a slant. And without moving it, draw on both sides of the ruler in order to make parallels the slant. Now mine's going to be really skinny if I do this. But you're creating a parallelogram then. And we should be pretty confident that your opposite sides are parallel. Lines on the paper and then you use the sides of the ruler. Okay? All right, I would like you to do some measuring. So with your ruler, measure all the sides and all the angles of that parallelogram. measure all the sides, measure all the angles. Get those measured, I'm gonna have you try to pull up an app that I've used before that I'm not sure if you can do the measuring on or not, on the free version. Yeah. And the one that I want you to do was Geometry Pad. I think we've downloaded that one before, maybe not. Okay, so we shouldn't have to redo it. We'll see if you can get a parallelogram made on that app. I think down at the bottom, you might be able to select one that is a parallelogram. But I have the paid version, and so I'm not real confident if you can do the measuring. So you can pick parallelogram. And tap some points. And it finishes the parallelogram when you drive. Now, are you able to measure the sides and the angles? That's the part I'm not sure if that's in the paid version or the free version.
Measure the size.
You want to measure the sides? Geometry Pad. It's showing me an angle, but I don't know what angle that is. It's saying 230 something. If you pick the one that looks like a protractor, or excuse me, compass. No, I guess it's protractor. The one that looks, do you have that?
Can't open.
Okay, so that's the one that has to be a page. So you can measure the sides but not the angles. Yeah, how much is it to buy? $7, that's kind of steep, isn't it? Okay, so that's what I was thinking, that you weren't able to measure everything that I would want you to be able to measure. Let's see, 6, 7 times 20 something, is that worth $140 for us to do? You could try GeoGebra, but I think in GeoGebra, you cannot ask it to just come up with a parallelogram. You have to actually create the parallelogram. You might be able to find one, I guess, that has already been created. try that in GeoGebra. Try in GeoGebra. I know I have some created in my GeoGebra, but I have to figure out if I can get those to you through the app or not. Some more things to try and figure out anyway. Search GeoGebra materials, can we find a parallelogram? Looks like there's some that maybe have what we would want. I pulled up one that was parallelogram by Hannah somebody. I go back, what will it tell me? Hannon, I guess it wasn't Hannah. Hannon. Theo. Can you find that one when you search the GeoGebra materials? I did view. Yeah, and now I touched on like one corner of it and I could slide the parallelogram. So the angles changed. So what are you finding about the angles between the one you did manually and the GeoGebra ones that you're finding? Anything you see about angles in parallelograms? Are you able to get to that one? We could probably find a different parallelogram one. Are any of the angles the same? Yes, which ones? The opposite ones. Are any of them supplementary? Okay, everybody's looking at something? All right, so you're finding for me that the opposite angles are congruent. Look at the consecutive angles. Like one angle and then the very next one going around it. What relationship do they have on your measurement or on the one that you're finding on the GeoGebra? Says they're supplementary. They add up. I know they've got some decimals unless they've rounded it. They add to be 180. Now, why would that be? If I consider angle A and angle D, why would those be supplementary? Remember our theorems about parallel lines? So if you use like the bottom and the top as my parallel lines, and this side is a transversal, what angles are those two? Are they corresponding? They're same side interior. The same side interiors were supplements. So those two should always add up to 180. Same with A and B, they should always add up to 180 because of the parallels going this way. Same with B and C, C and D. So we've got consecutive angles being supplementary, opposite angles being congruent. How about side measurements? Are all the sides the same length? On the ones that you did, are they all the same? No? Okay. How about the ones that you're finding online there? Are they the same? As you stretch them, do the side measurements change? Do they all stay the same? Which sides are equal? Forget that I was done playing with it. The ones across from each other are congruent? Correct. Seeing which ones you guys are messing with. All right, so the opposite sides are the same length. Now there's something that I want to explore that is not in that diagram. I know if we chose just edit, we might not be able to change, or view, might not be able to. Can you get the diagonals in? Can you put the diagonals in the diagram? Probably add a segment is what you would have to do. You might have to be in editing it instead of just viewing it to do that, I suppose. Here's kind of an interesting one. Let's see, who is this one by? It's Harris, somebody Harris. See what you can find out about the diagonals. Either on your paper pencil one or on either a geometry pad. You can probably go back to that and add your diagonals. Or in the GeoGebra. There's one. I'm going to get the name here in a second. There's one that says Parallelogram Investigations. And the person was Jay Harris. That person has some things that you can click on the side. Looks like there's one with Mandy Peterson also. Got some clickers. If you click the diagonals, puts them in there. Click the diagonal intersection. Diagonal angles. That one's kind of a neat one. Shows you the lengths as you click on them. Are the diagonals the same length? Some of you are trying to make your own. So one thing I want to know is, are the diagonals the same length? So quiet, you guys are really looking up stuff. You should be finding the diagonals are not the same length. But what is true about them? Is it unique that the two diagonals make vertical angles that are congruent? That really isn't anything new. But have you got to something that measures the two halves of the diagonal or the two parts? Did you find something that showed you the measurement of that part? Like just going to that center point? You should find that those two are the same length. And these two are the same length. So it's not the same total, but they're cut in half. So they bisect each other. Yes, it does create vertical angles that are congruent. It does make some littler triangles. Let's see, one more thing before we kind of call it quits on investigating. Does this diagonal bisect the angle? It should not. I think on one of those parallelogram investigations, you could maybe click on the angle, diagonal angles, I think is the one I clicked. And it shows you the angle, the two separate angles on the corner. It does not bisect them. They bisect each other. So that'll give you something good to play with during fifth period if you don't have anything else to do. All right, let's kind of flip those over so we can get our notes written down. So what was the best thing to look at? Was this parallelogram investigation one the best one to go to? Or was creating your own in GeoGebra? No, that worked for you? All right. Okay, our theorems. So some of the things that you just looked at are in the form of a theorem. Okay, theorem 621. If a quadrilateral is a parallelogram, then its opposite sides are congruent. So the hypothesis is you have to have a parallelogram. Right. Anybody not here to get the packet of notes? Okay. If a quadrilateral is a parallelogram, then its opposite sides are congruent. Hypothesis is you have to have a parallelogram. Conclusion, the opposite sides are congruent. Opposite sides being parallel was the definition. Another theorem. Finished with that one? Anyone still need it? 622. If a quadrilateral is a parallelogram, then its opposite angles are congruent. So your hypothesis again is you need a parallelogram. Whether you want that in picture form or word form is up to you. Conclusion is that angle A and C are congruent, angle B and D congruent. How can I tell if those are the opposite angles if I don't have a picture? Remember when you name a shape, you're going around it consecutively? So if it's consecutively going around A, B, C, D, A and C would be the opposite corners, B and D would be opposite corners. Okay, 623, If a quadrilateral is a parallelogram, then its consecutive angles are supplementary. So that would be one corner and then the very next corner. They add up to 180 degrees. And so on as you go around the shape. That is simply based on parallel lines and transversals being the supplementary same side interior angles. And of course, you'll be able to interpret what supplementary means and come up with some equations. Okay, done with the notes? Sorry, since I interrupted you. Okay, and the last one was that its diagonals bisect each other. Now realize what bisect each other means is that they cut each other in half. So Z is the halfway point, ZB and ZD are the same, ZA and ZC are the same. That is not saying that it's the same total, because when you go from the acute angle to the other acute angle, that's longer than if you go from the obtuse to the obtuse. And you can emphasize that by these little sticks that I have, I guess. We can make them look about the same. If we go this direction, you can see that the diagonal that would be connecting here, the obtuses, gets a lot shorter than the other one. This is a chapter that if you forget some of the theorems, you can draw yourself a diagram and have a feel for what it's going to say. If you're trying to investigate something about a parallelogram, you don't want to draw a parallelogram that looks like a rectangle or a square. You would want to draw a real slanted parallelogram to investigate things about it. Otherwise, you'll get some properties that really are not true all the time. No? All right, let's try some practice problems. In parallelogram, so this symbol, don't overlook it. That tells you a lot. That is a parallelogram. Parallelogram, CDEF, it gives you some measurements and angles. Find CF and give the support. So we want to refer back to those theorems or definitions for some support. Think about that one. What's the length of CF? 74, why?
Because of theorem 621.
621, the opposite sides being congruent, correct. How about that same picture, find angle EFC. EFC. John, have you decided on this one? Sam, you want to help him?
Oh, yeah.
How are you getting that?
Here.
623 says consecutive angles are supplementary. So if FCD is 42, then EFC would be its supplement. So that was how we got 138. The diagonals in there might be kind of distracting. So if you want to draw that picture without the diagonals, it might help you visualize what's going on there. All right, let's go with, okay, this time find DF. DF is one of the diagonals. What's the theorem say about the diagonals? The last one? No? Okay, what's that mean? Derek, what's that mean? Clarify what you mean by they're both congruent. Okay, so DG and GF are congruent. I want to make sure you're not meaning that DF and CE are congruent. I think that's what Riley meant. Yeah. At least that's what I interpreted what you said is. So this one is cut half and half, the other is cut half and half. So if we know DG is 31, then GF is 31. And so this whole diagonal is 62. So that's how we would get to that one. The 31 times 2 is 62. Make sense? All right, how about basketball season? Is it March Madness starting today or tomorrow? Playoff games? Nobody's focused on that? Oh, big stuff in the news, huh? All right, so in this basketball support, in parallelogram KLMN, it gives you measurements, find KN. Why don't you grab your marker board for me on this set? That way I can see more of you at one time. Find the length of KN and give the support. So if you'll either give me the theorem number or say it's the definition of a parallelogram. Show me. Is it ready? Oh, the number's not right. Okay, that one should have been 28 inches, and it was the theorem 621. That's support. How about find angle NML? And give the support. That was 74 degrees, theorem 622, because the angle that you were given was across from it. So it was the opposite angles that were congruent. How about length of LO? The length and the support. More to show me? Support? No. Length isn't right. Actually, your length wasn't right. The theorem's right, but not the length. It was theorem 624, diagonals bisecting each other, and LO was half of LN. So 13 was the correct length. All right, how about this one? Find YZ. I don't want you just to say it is 8A minus 4. No. I want you to find what A is and substitute in. So how could you find A? Okay, set it equal to the other opposite side. These are good. Those are all looking good. So you've got something written wrong here. There was a 6A plus 10. So you had the right idea, just wrong numbers in there. All right, so on that one, the A comes out to be, I think it was 7. So then when you substitute it in, 52 degrees, or 52, I guess, length. Okay, same picture, find measure of angle Z. It's angle Z. How can you figure out B? So you can substitute in. The two angles that have the B on them, are those congruent? They're not. They're not the opposite angles. They're the consecutive angles. So those two angles should add up to 180. be on that one? Was it 4? All right, any others to look at? B was 7. And then when you substitute back in, 9 times 7 plus 2 came out 65 degrees for the final answer. With the diagonals in there. Find JG. What's it say about diagonals? No, it doesn't say they're congruent. What's it say? They bisect each other. So each one's cut in half. A few more to see. Four plus 8. Okay, that answer should have been 12. W was 4, and then substitute in. And FH, about the same, but be careful how you answer the question. I'm asking for FH. What number did you measure? Okay, I was thinking 12. Okay, yes. So what's different about this one? It's really just at the end. So you set the 2z and the 4z minus 9 equal. And you solved and got z to be how much? Z was 4.5. Okay, then I asked you what FH is. So if you find like JH to be 9, then FH is double that. So 18 is the final answer. So do you know how to finish it out? Okay. Now something a little bit different. Go to the graph side of your marker board. I'm telling you 3 corners of a parallelogram. I want you to figure out what the 4th one would be. Remember when you name it, when I'm naming it JKLM, that's going consecutively around it. So that'll help you figure out which corner you're missing. J is this point, graph that. K is the next point. Those are connected according to the name. L is the next one around it. But then I didn't give you the 4th corner. But I want it to be a parallelogram. Can you find the correct corner to make a parallelogram that's called JKLM? What's that corner? Who's that? Is that your phone or your laptop? I don't get as many phones this year. People are on their iPads more. I think that second number's wrong. Okay, how are you doing this? Are you counting like the slopes? Did you think about that? You need the opposite sides to have the same slope to make them parallel. So I was counting like up and over from K, and then from J I went up and over. The answer should come out to be 7, -4. Not everybody showed me that. Does it make sense how you would do that? Count the slopes to make sure the opposite sides have the same slope. Now the next one's a little bit more tricky because of which point I left out. I gave you P, Q, and S. Look at the name, PQRS. So figure out where R comes in the right sequence to make it parallelogram PQRS. Right, this one was a little bit more tricky because of that other point needed to be up and to the right in order to make it PQRS. So that should have been the 0.76. So maybe connecting P to Q and P to S so that you can see your last corner has to be up that direction. All right? Understand that one? And the last thing is a proof. Okay, we've got a parallelogram, that's all we're given. Can we prove two triangles congruent? We did this last chapter or many chapters ago. How can we prove triangle AEB? Can we get this triangle congruent to this one after just being given that it's a parallelogram? And that parallelogram given information really lets us do a lot of things. What would be something? We're looking for sides or angles that are congruent in those two triangles that I dotted. Okay, vertical angles that are congruent, which angles? Okay, so vertical angles are congruent. We can support that. Tanan,
To A, B, and D here. Congruent.
the segments?
Yeah.
Okay, segment AB congruent to segment CD, but what's your support?
That was 621.
621, was that the one with the
Yeah,
opposite sides congruent? Okay, correct. What would be another part of our proof?
BC,
BC. Now, I would agree BC and AD are congruent. The reason I'm hesitating, they're not in the triangles that I want.
Oh.
So maybe it might not help us too much. Gonna-
BE congruent to DE,
Reason?
624.
624, the diagonals bisect. Right now, we've got angles side side, don't we? So this combination isn't what we want. Keep going. What else could you come up with? CE, congruent to AE, what reason?
64.
That same 624, diagonals bisecting. Okay, so now we could do this by side, 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 and not even talk about the vertical angles. Or we could not even talk about these outer sides, and we could do side angle side. So it's easier than you thought? There's a lot of different things you could do. Something else we could have done was like alternate interior angles. So we probably could have done that by any method except hypotenuse leg, just depending what you put into your proof. So we kind of talked through that, but it's not as hard as you thought. Page 395, we got 10 minutes here. Okay. 10's better than nothing. Okay, on 395, we'll do 1 through 13, 26, 32 to 44, 46, and 47.